You're going to want your calculator handy for a few of these. So what we're going to cover for the majority of the rest of the quarter will be quadratics, but we have to have some underlying stuff first, which is what Chapter 8 is. We have to know how to deal with radicals, radical expressions, simplifying radicals, evaluating radicals, and then we'll also deal with complex numbers, okay? So we'll cover Section 1 today. We'll cover Section 2 on Monday. Your homework assignment is Section 1 and, I'm sorry, not 2, 3. Section 1 and 3, so you'll be able to do about the first half of it today, and then the second half of it on Monday, and then we'll do Monday night, okay? So starting with radical expressions. All right, just some foundation here. Radicals are different roots. They are the inverse or the opposite of our different exponents. So if I have the square root, it's the opposite of squaring a number. It undoes that operation. Third root, third power, fourth root, fourth power. That's that inverse operation. We can do that up to whatever number we want. The 1,000th root is the opposite of doing the 1,000th power. Okay? It undoes that operation. So some vocab that you need to be aware of. All right, when we're dealing with a radical expression, we've got three major parts. We have the radical sign that tells us, hey, we're taking a root. We have the radicand, which is the thing we're taking the root of. Okay, so that's the thing that we're trying to find the root of. And then most important is the index. If there's no number there for the index, we assume it's a 2 for square root. Okay? But anything other than a square root, we will include a number, 3 for third root, 4 for fourth root, so on and so forth, okay, to whatever power we need. All right, so being aware of the index is really important and what that value is. So just kind of a list here. Your calculator will do most of this for you, but understanding, again, the root and the exponent and that relationship they have. When I'm looking at, okay, what is the third root of 27? You kind of have to think, well, 3 to the third power is what gives me 27. So what number to the third power gives me my radicand? 3 to the third power gives me my radicand. So the cube root is 3. Your calculator will evaluate these. Your TI-84, if you want to do square root, it's listed here above the x squared. You just have to use the second key to get square root, and you can plug in a number like 16 and get your square root. If you need to do third root or higher, it's going to be listed underneath the math function. When you click math, it gives you your list. 4 gives you third root automatically. If you need something higher, you have to go down to 5 for x root. And you can plug in your x root. And if I wanted to do the fourth root of 256, plug that in, and that's going to give us our value. For the fourth root. We could do that with fractions as well within our math. Math, hold please. Harris? Well. Yes. Yes. No. Yes. Okay. We can do our roots with fractions as well, so I can put in my fourth root, and I can put in my fraction, 16 over 81, and it'll give me my root. Okay, those evaluations for us, even with the decimals and so on. With that, it's going to make your life easier. Some rules with our different roots. All right, if our index is even, we have 2 possible answers, and we have to make sure that we have a way to delineate which answer we want. If I take 3 and I square it, I get the same thing as if I split 3. So if I'm working backwards and I'm square rooting 9, we have to have a way to delineate between, do I want a negative 3? That's the difference between principal root and negative root. If there's no sign listed in the front, then we want the positive root. If there's a negative, then we want the negative root. But again, that's only for even indexes, okay? Only for even indexes, 2, 4, and so on. If, again, our index is even and our radicand is negative, we have a negative value there, then the solution is not a real number. When we cover section 7, which is complex numbers. Then we'll do stuff with those. We'll deal with our imaginary unit. We'll deal with I and the negative roots. But for now, for the first couple sections, we're just going to leave it as non-real. Okay, we're just going to non-real and leave it at that until we expand on it. So both of those rules apply for even indexes only. If my index is an odd number, 3, 5, 7, 9, and so on, then we'll only ever get one root. We don't have the difference between positive and negative because I can take the odd root of a negative number. I can do the cube root of negative 27. I can do the cube root of positive 27. Those are going to give me two different answers. If I raise a positive number and a negative number to a third power, a fifth power, a seventh power, I get two different answers. Okay, one positive, one negative. So odd doesn't have that same setup that even indexes have. So you need to be aware of those. All right, so real quick, we can go through some of these roots. All right, so if I take the square root of 36, what do I get? 6. If I take the negative square root of 36, what do I get? Negative 6. That's the difference between the principal root and the negative root. 6 or negative 6. The fourth root of 16. 2. The negative fourth root of 16. Negative 2. Again, principal root, negative root. Fourth root of negative 16. Not real. Okay? We'll deal with our imaginary numbers later, but for now we're just going to state that it is not a real number or is a non-real number. Okay? Even indexes on all of those. Square roots and fourth root, even indexes. Fifth root, odd index, doesn't have the same restrictions. What is the fifth root of 243? Use your calculator. 3. The fifth root of 243 is 3. What is the fifth root of negative 243? It is real. Negative 3. Remember, even indexes, negative radicand is non-real. Odd index, it's always going to be real. We'll always get a real value when our index is odd. So if I have the fifth root, the seventh root, the third root, the 171st root, okay, any odd index is always going to have a real root. A couple other special things to keep in mind. We have the square root of a squared term. Okay? Squaring the square root. Those are inverses. They cancel each other out. But because those principal roots, I can't have negative radicands, we have to kind of have this safeguard in to make sure that we don't end up with something that actually isn't real, and then we say it is real. So that's what this whole absolute value is for. We don't have to evaluate because the exponent and the radical will cancel from each other, but we still have to make sure that we put that in absolute value so that we don't end up with something negative that can't be negative. So just some examples kind of worked out. You don't really need to write anything here, but just kind of notice that if I take this square root of 15 squared, if I were to expand that out, get 225, and then take the square root, I end up back at 15. Okay? So these cancel each other out. I just need to make sure that I have the absolute value. We see the big difference here. If I were to just cancel these out and write negative 12, well, that's not going to be correct. Because what happens when I square negative 12? Square any number. You always get what type of number? A positive value. So if I square negative 12, I get positive 144. And then when I take the square root of that, I get a positive 12. So if we just cancel it out, we see, well, it doesn't give me the correct answers. Therefore, that's what the absolute value bars are for, to make sure that we end up with the correct root of positive 12. Okay? Easy enough to work through when we have numbers, when we have real numbers. When we have variables, it's even more important.
Is there always going to be a 2 outside of the radical sign? Like no matter what? Like even
if there's no number there, it is assumed to be a 2. Okay? So here when I have my variables, all right, I want to cancel these out, but I don't know what y is. Y is everything. Y can be anything. Y can be a negative number. So I need to make sure that when I evaluate, I still have a positive result. So we have to leave the absolute value bars there with the solution. Same thing here when I have the square root of negative y squared. Those cancel out. I have negative y in the absolute value. Well, we can simplify that because no matter what, we're going to end up with something positive. So we can get rid of the negative and just leave it as the absolute value of y. That rule applies anytime we have any even index. Even indexes only. Even indexes only. Even's the only one that has those special rules. Okay? Because we have principal root, we have. So any even index, if the index and the exponent match, square root, fourth power, sixth root, sixth power, eighth root, eighth power. When those two numbers match, when we cancel out those terms, we have to remember to put the absolute value bars in. Okay? If we have an odd index, we can just cancel it. No need for the absolute value. All right? So we only use absolute value when n is even, not necessary when n is odd. Look at both of these and we need to see how they match up. So if I have the fourth root of negative 5 to the fourth power, we need to see first, do they match? Yes. Are they even? Yes. Then we need absolute value. Okay? If they match and they're even, absolute value. So we can cancel those as long as we put negative 5 in absolute value bars. And what is the absolute value of negative 5? 5. Okay? For B. Yes, ma'am.
I have a question. If we were taking a quiz, would you need to put both? Like, what answer would be your final answer? Would it be in the bar?
It's a real number, you're just going to put 5. But for variables, that's going to vary depending on what you have. We'll find as much as you can. B, do they match?
Yeah.
Yes. Are they even?
No.
No. Do we need absolute value bars?
No.
No. So we can just cancel them out. The fifth root of negative 5 to the fifth power is just negative 5. C, do they match? Are they even? Do we need absolute value bars? Yes. But pay attention, we have an additional negative on the outside. So that negative will be outside of our absolute value bars. So when we take the absolute value of negative 3 and then make it negative, what do we end up with? Negative 3. All right. D, do they match? No. Absolute value bars aren't going to be necessary. I'll show you why. Okay. If we were to go through and continue to simplify this, all right. So we've got our variable. We can actually rewrite m to the 8th as m squared to the fourth power. That's our power rule of exponents. If we multiply the exponents to 4, we get 8. So we can break that apart. Okay? There's a couple other ways that we could also rewrite it if we needed to. But now, they match. So I can apply the rule, and I can go ahead and cancel those. And I have negative absolute value of m squared. Okay? So whenever I take the absolute value, what does that do to my number? Makes it positive. Whenever I square something, what else does that do to my number? Make it positive, right? So both absolute value and squaring will make my number positive. So if I'm going to have to square this number anyway, and it's going to become positive, are these absolute value bars changing anything? No, they're redundant at that point. Okay, so we don't need them because if m was negative 3, when I square it, it's not going to be negative 3 anymore. It's going to be positive 9. So I don't need the absolute value bars because they're not doing anything extra. The absolute value bars are redundant, so we can simplify to just negative m squared because the squaring will take care of making it positive. Questions, comments, concerns, queries?